All right. Good morning, good afternoon, good evening, ladies and gentlemen. Welcome to this series of online lessons. If you haven't already, subscribe to the channel and leave a like for this lesson. Now, in today's lesson, we'll be looking at systems of equations and how we can find solutions to systems of equations by using different methods. So this will be a series. So first of all, let's say if we have an equation 2x plus 3y plus z equals to 4, this is just an equation. But if we have more than two equations, we call that a system of equations. Okay? And basically, if we have two, let's say 3y plus 7z equals to 4, this becomes a system of equations. And we can solve for x, y, and z for this system of equations by different methods. So we can use row operations, which I feel are the easiest. Then we can use the substitution method. This is the normal substitution that we use. So for row operations, we're going to learn about two things, that is using Gauss elimination and using Gauss-Jordan elimination. So Gauss-Jordan elimination. Okay. Then substitution, this is just a simple where we make one of the variable subject and we replace in the other. Then we also have we also have Cramer's rule. Yeah, Cramer's rule, which requires to find the determinant. So for Cramer's rule, it only works if we have an equal number of equations as the variables. So it's a bit limited in that sense. So for Cramer's rule, we need to have an equal number of equations as the variables. But for row operations, we don't need to have an equal number of variables as the equation. So as you can see here, we have 1, 2, 3 variables and there are only 2 equations. So this would be very difficult for us to work out using Cramer's rule. But if we were to use row operations by basically Gauss elimination and Gauss-Jordan elimination, it is much easier. Okay, so we will start with row operations. So under row operations, I am assuming that you know how to use row operations. So these are things that I am assuming. You know how to use row operations to simplify a matrix to echelon and reduced echelon. Okay, so that is what I'm assuming. You know how to use row operation and how to reduce a matrix to echelon and reduced echelon, but I will be giving lighter notes on how to reduce a matrix into an echelon and into a reduced echelon. Then I hope you'll be able to catch on from there. But if you have any problems, then you can just ask me, then I'll be able to help. Okay, so let me just erase. I think we can even start with the same questions that I just made up here. So we are using row operations to solve this system of equations. So solve using row operations. Okay, so solving using row operations, what you have to do first of all is make sure that we align the variables. Okay, so on one side we should have variables, whatever variables that we have, if it's x, y, and z, and on this side of the equal sign we should have constants. Okay, as you can see here, then we align variables like we have done here. So we have x, and there is no x part here, so we can just say 0x plus the y's are in the same like column, and the z in the same column, and the variables. Now what we have to do here is we will change this into a matrix, which is a blocked matrix. So what we do is we say this will become 2, down here we have 0, then we say 3, down here we have 3, then we say 7. Oh, I mean, we're getting the coefficients here. So the coefficient of x is 2, the coefficient of this part of x is 0 because there's no x part. Here we have 3, down here we have 3, the coefficient there is 1, and the coefficient there is 7, and we block it with 4 and 4. Okay, so I'm just showing you how to get started, then we'll move on from there. So first of all, you have your matrix or your system of equation. Make sure you arrange them nicely. You check the equations, you array them according to the variables, then you form a blocked matrix like this. Okay, you form a blocked matrix like this. Okay, this is a bad question to start on because it introduces concepts of free variables, which would be requiring us to, yeah. So but let's use a different question from this one, because this one we'll come back to it, because this one introduces the concepts of free variables, and we have hardly done anything on systems of equations, and we go directly to free variables. So let's suppose we have a system of equation 2x plus 3y plus 7z equals to 4. We have negative 2y plus z plus 3 equals to 5. Then we have 8z minus 2y plus x is equals to 0. Okay, so suppose we have a system like this. Okay, so the first thing we said is we have to make sure that we arrange the variables in terms of their columns. So we make sure that on the first part of the equation we only have variables, and on the other part we have a constant. So we have x, y, and z. So we're going to have 2x plus 3y plus 7z equals to 4. Then here we start with x. Do we have any x here? So we have 0x, so that will be 0x. Then the second part is y, negative 2y, then plus z. So we take the constant on the other part of the equation there, it will be 5. When it comes there, it will be minus. So 5 minus 3, that will give us 2. Okay, then here we start with the x part, which is x. The y part, negative 2y. Then the z part, 8 plus 8z equal to 0. Okay, now once you've done that, you need to form a block matrix. So what you just do is you just get the coefficients. So the coefficients of x here is 2, 0, 1. The coefficients here is 3, negative 2, negative 2. The coefficients here are 7, 1, 8. The coefficients, the solutions part is 4, 2, 0. Okay, so we have formed a block matrix. Now there are two methods that we should know. Okay, so let me just put it on the corner here. Is first of all, I talked about using Gauss elimination. Okay, using Gauss elimination, it requires us to reduce a matrix into echelon form. So this requires us reducing to echelon form. Okay, how does an echelon matrix look like? Okay, so first of all, the first element in a column should be any number. Okay, but the leading element, which is a number, down below that there should be a 0. Okay, and down below that there should be a 0. Okay, let me just say below each leading element there should be a 0. Okay, it's more like an upper triangular matrix. So we need to make this part a 0, this part a 0, that part a 0. Okay, and we form an echelon matrix. Okay, yeah, we can also make a 0 there, but we form an echelon matrix by doing that, which is just an upper triangular matrix. So we need to make a 0 here, 0 here, and a 0 there. So here we already have a 0, so now we need to make a 0 there using row operations. So we need to think about two numbers that we can multiply with each other so that they give us a 0 there. So I'll give you a trick here. So we are trying to change row 3. So this is row 3. So we are trying to change row 3. Okay. What we can do is we can say on row 3, what number is there? There is a 1. So we can say this 1 times this row that we want to use, which is a row 1. Okay. And since there are no polarities here, we say minus this 2 times row 3. So this will give us a 0 because 1 times row 1, it is 2, minus 2 times row 3 will be 2, which will give us 0. So we put an arrow like that to show the direction of the transformation. So since we are changing row 3, row 1 remains unchanged, which we have 2, 3, 7, and 4. Okay. Then row 2 also remains unchanged, which we have 0, -2, 1, 2. And now row 3, we say on row 1, so let me just do this. Row 1 times row 1, so 1 times 1 here will be, 1 times row 1, this is row 1, so 1 times row 1, where there is a 2 there, okay, minus 2 times row 3. On row 3 here there is a 1, so when we say 1 times this minus this, it will give us a 0 here. Okay, then we go to the next part. So we need to do this for the entire row. So here and here, 1 times row 1, so that on row 1 here there is a 3, so that would be 3 minus 2 times row 3. On row 3 here there is a -2. Okay, so we are doing all this, so this and this. So 1 times row 1, on row 1 there's a 3 minus 2 times this, so this will give us 3 minus 3 plus 4, which is just 7, so this will be positive 7. Okay, so we do the same for the other part until we finish the entire row. So 1 times row 1, on row 1 there is a 7 here, so 1 times 7 minus 2 times on row 3 there is an 8. Okay, so that will be 7 minus 16. giving us -9 there. So we do the same for the blocked part. So we say here, let me just erase this. For the blocked part, we say 1 times row 1. On row 1 there's a 4 here, so we say 4 minus 2 times row 3. Row 3 there is a 0 here, so it will just be 2 times 0, which is 0, and 4, this will be 4. So I also urge you to write out like the way I am. So you see I was writing out these numbers. It minimizes the possibility of errors. So write them down, try to work them out step by step, and you'll be good to go. So now we have made a 0 here using this. So our goal now here is to make a 0 here. Okay, now making a 0 here, we cannot use this row because this row has a number there which will affect this. So we can only use a row that has equally a 0 there. Okay, so need it be, we were supposed to make that part a 0 as well, so that we can now use this to have 0. So here now we need to make a 0 there. So making a 0 there is very easy. So again, we just use the same trick that we learned. So we're trying to make a 0 in row 3, which is here. So we can say on row 3, we're trying to make a 0. This will transform to, we can swap the numbers, which is -2 times row 3, and -2 is in row 2. Then we say plus 7 times row 2, more like the way we do when we're doing the elimination method, where we just swap the numbers. This comes there and that comes there, and we consider the polarities. So if this is negative, one should be positive, and so on and so forth. So yeah, so we can say, oh, since there's already a minus there, so there's no need for me to put a minus there. So this is what I'm saying about considering the polarities, the signs. So we said 2 times row 3, that will be 14, plus 7 times -2, that will be -14, and these will subtract out to give 0. Okay, so I'll write out my matrix. I need to put an arrow there to show the direction of the transformation. So let me write out my matrix. Row 1 is unchanged, which is just 2, 3, 7, and 4. Here we have 0, -2, 1, and 2. And now when it comes to row 3, here we have 2 times row 3. On row 3 there is a 0, plus 7, so we say 2 times 0. 7 times, on row 2 we have 0 here, so this will give us 0. Okay, so move on. So that will give us a 0. Then we can do another one. Okay, so it will be 2 times, on row 3 there is a 7, plus 7 times row 2. On row 2 there is a -2. So 2 times this, that will be 14, and this, that will give us a 0. So this would be a 0. Okay, then here we say now we go to the last one. Oh, we still have one more, so the second from the last. So we do now 2 times, on row 3 there is -9, plus 7 times, on row 2 there is a 1 here. So that will be 2 times -9, -18 plus 7. That will give me -11. So this is -11 there. Then we do the last part here. Okay, so let me just erase. So that you can follow through properly. So this is 2 times, on row 3 there is a 4, plus 7 times on row 2 there is a 2. Okay, on row 2 there is a 2, so this times this, that is 8 plus 14, so that is 8 plus 14 should give us 22, so this is 22. Okay, now when you reach this page, remember the way the variables were arranged. So we had x, y, and z. Okay, so same applies here. The diagonals, this will be x, this is y, this is z, and these are the solutions. So now if we are using Gauss elimination, we do what we call back substitution. Okay, and basically it's just taking back these into equations form. So we have 2x, it will be, so the first row will be 2x plus 3y plus 7z equals to 4. Here we're going to have negative 2 plus z is equals to 2. And the last one we have negative 11z equals to 22. Okay, then now we start from the bottom to find the variables. So we can start with the first equation. So that is negative 11z equals to 22. You can say over negative 11 over negative 11. That is 22 divided by 11. That will be 2. So z gives us 2, negative 2 to be precise. Okay, then after we find our z, we can find our y using this equation here. So we replace our z here, so it will be negative 2y plus z, which is negative 2, will be equal to 2. Okay, then when we make y subject here, so this goes there, that will be 4. Y is basically equal to negative 1. So so this will go there, it will be 2. Will it be 2? I'm sure it will be 2. So this will be negative 2y equals to, this goes there, it becomes plus, so it's equal to 4. Then we say over negative 2 over negative 2. Y is equal to negative 2. Okay, we have our z, we have our y, so we can find our x using the first equation here. So we'll just say 2x plus 3, and our y is negative 2, plus 7, and our z is negative 2, equal to 4. Okay, let me just do this. So this is equal to 4, and so this is equal to 4. So now we can simplify this as 2x, then this will give us negative 6, negative 14 is equals to 4. We take this on the other side, we're going to have 2x, so that will be equal to, so this is 16 plus 14, that is about 20. I mean, is it 6? Yeah, 6 plus 14, that is 20. So when it comes this side, it will be positive 20. So I just want you to take the steps. So this would be 4 plus 20. Okay, then x would be equal to 4 plus 20, that is 24. Then divide by 2, divide by 2, then divide by 2, which is just 24 divided by 2, which will give you 12. And there you have it. So you have your x equal to 12, your y equals to negative 2, and your z equal to negative 2. And you have solved this system of equation using Gauss elimination. So using Gauss elimination, So we'll come back to the first equation here where we talked about three variables, which is very useful as for systems that have. So whenever you have a system that will not have the same number of variables as the other, means there is a free variable. And the free variable is basically just a variable that we assign to a particular value. So now let me just give you some questions where you're required to use Gauss elimination. All right, so you have these two questions. Solve the following system using Gauss elimination. And yeah, so this is a good start. So just have two equations. You can just pause and copy them, and I'll be waiting for your feedback. Have a great evening.